This video lecture is a continuation of the walkthrough for hurricane exercise part 3. So far we've looked at we've been looking at the data on damages and deaths from tropical cyclones in the North Atlantic since 1900. The data set that we used allowed us to look at damages both in terms of nominal dollars, which we converted to real dollars, and then we looked at the summary stats on that. We composed histograms to look at the data distribution, both in the original form but also modified to look at an exponential distribution, or rather binning, so that we could see the pattern of smaller numbers of events. We then looked at trends to see whether there is a trend, an obvious trend, both in deaths and damages, and both of them show the suggestion of trends, although the trend lines aren't particularly good at describing the data. Nevertheless, the damages looks particularly convincing, I think. So next thing we're going to look at is the relationship between death and damages. And so in a statistical context, when you say relationship, what you're looking to see is whether there's a correlation between the two data sets, to see whether when one data set moves or changes, does the other one move in a similar or systematic way. So for example, if you have more deaths, do you also get more damages? If you have more deaths, do you get fewer damages? And what is the relationship between those two in that sense? So in order to look at that, we're going to start off by constructing what's called a scatter plot. And the scatter plot is always where you begin when you're interested in looking at the relationship between two sets of numbers to see whether there's a correlation. So what that means is that we need to get the data both from the deaths and damages. So I'm going to highlight the values in the deaths column first. Not that it matters, the order doesn't really matter in this case. And then I'm holding the control key down on my keyboard and highlighting the data in the damages column. Right? So when I highlight those two columns separately, now I'm ready to insert my graph. And so what I want to do is put in a scatter plot. So it's going to be that little dotted plot right there. And I'll choose that first one right there. And so this is the resulting plot that I should see. So we're going to move that chart to its own sheet. So we'll say death times damage. Okay. And so what we're looking at here, we can see on the vertical y-axis the damages, and on the x-axis we see the deaths. So we'll name this graph to make it so we know what we're looking at. So this is deaths versus damages from tropical cyclones, 1900 to 2019. Okay. All right. We should label this too, because it's not obvious what this is about. So I want to label the x-axis so we know what that is. So I'm going to add a chart element there. So I want to add an axis tile to the primary vertical. So down there I'm going to add, this is deaths, so we know what that number means. The dollar sign I think is pretty obvious, but this is not so obvious. Okay, what are we looking for? Well, when we're looking for correlation, what we're looking for is a particular arrangement of these points. So each point represents the intersection where you have damages and deaths. So for example, that point means that you had 60 deaths and 66,000, or if you billion, millions in no, that's billions, a billion damages. You see the confluence of those two numbers. Similar here, we can see that we have a situation or an instance where we have this amount of damage and that many deaths. Now, what we're looking for is we're trying to see if there's an obvious pattern to the relationship between the two sets of numbers. So there's several possibilities. One is that there's no relationship, in which case there's no obvious pattern. But the two others that we're looking for is a situation where there might be either a positive relationship, and positive not in a good sense, but positive meaning that when one value goes up, the other one goes up. So if we saw a positive relationship, what we'd expect to see is that the points would sort of create a line or maybe a cloud that kind of rose from the lower left corner to the upper right, and that would indicate a positive relationship if we saw that pattern. The alternative would be what's called a negative or inverse relationship, and it would be the opposite of that, where the line or a cloud of points would kind of run from the upper left to the lower right, and that would mean that is one value. Let's say damages went up, deaths went down, or vice versa. When deaths are up, damages are down. So one of those two situations would tell us, one, there's a relationship, and two, would be somewhat indicative of the type of relationship. But again, when we look at this data, it doesn't seem to be like, it doesn't look like anything going on here. It just looks like something exploded in the lower left corner and just shot outward. So there's no obvious linear pattern here. But we know that one of the issues with this data is that data is not normally distributed, and that affects what we see pattern-wise in graphs, which is why we're often thinking about how the data is distributed and oftentimes how we can transform the data to make it, as I say, behave or reveal patterns that might not otherwise be apparent. So I suspect this is going on here. In fact, I know it is. So let's go ahead and let's adjust these numbers to see what it shows us. So we've done this before. We know that when we have numbers, again, where the small numbers kind of get overshadowed by large numbers, we have a large range. Sometimes taking the log of those values, transforming them that way, can really make a difference. So what I want to do is I want to take the logged values of deaths and the logged values of damages. So I'm going to insert a new column right after deaths here. So I'm going to right-click on the G column up there and choose Insert to insert an empty column there. And I'm going to call this log 10 deaths. Okay. And I'll widen it just a little bit so we can see that column. And over here, I'm going to say log 10 damages. All right. Okay, let's start with the deaths first. So taking the log of a number, right, if you recall from before, means that essentially we're saying, you know, what do you have to raise the power of, 10 to the power of, to get that number? But it's a very simple formula. So we can take log 10 of the number we want to get. So we'll take it of that number right there, right? That's how the formula looks. And so that number represents what we'd have to raise to the power of 10 to get that number. It's actually not quite 4, so let me expand that value out so you'll see how that number, so basically 10 to the power of 3.9 would give you 8,000. That's what that number means. So we have that formula, we can copy it downward, but as you do that, you may notice that we have this problem here. You'll see that this is in fact an error message, and this will not, the error itself won't actually tell you what the problem is. The issue here is that the log of 0 is mathematically undefined, so it doesn't make sense. So from our purposes, what we want to do is we want to be able to handle this data so that we can graph it out. So one way to do that is to kind of override that error by telling it to ignore it and replace it instead with 0 whenever it encounters a 0. So we'll just leave it at that. So the way that we can do that is to modify our formula a little bit. So rather than just doing the formula straight away as it is, we're going to add an element called if error. Okay? And so if error will wrap around our initial formula. And so what we'll say is that in the if error formula, we'll say, okay, give us the log base 10 of that number, but if you get an error, replace it with a 0 instead, right? So that's that last bit here. So then we close off the formula. So you see how the formula looks right there, and I'll hit enter. All right, so it doesn't change the original, the actual formula itself, but if I copy it downward, you'll see that now that error goes away and it's replaced by a 0. So anytime it encounters a 0, it's going to basically put a 0 in that place. So we can continue then copying the formula down, and you can see that all the zeros are just replaced with 0, so we kind of get away from that issue, that problem there. So we'll copy that down to the 2019, so we've got the log values of deaths, and we're going to do the same thing with damages. The nice thing is we've already defined the formula, so we don't need to write it out again. So we'll just copy that formula and paste it over here, and then copy it downward too for the remainder of those years. So we can see then that we get our log values, and then the few instances where we have 0 doesn't cause a problem. So now we're ready to try out to see what this graph looks like when we take these log values. So again, I'm going to highlight these. Now I'm going to highlight the first row too, because this way it'll label the values so we know what they are, because since they're logged values, they're kind of hard to they're not obvious which is which. So I'm going to highlight all those. Okay, and then we're going to insert a new scatter plot. Okay, just like before. And we see that. And already you can see that the cloud looks a lot more linear. So let's add this, let's move this chart to a new sheet, okay, and say death by damage log, death by damage log, yep. All right, and so you can see that cloud of points definitely has much more of a linear pattern to it, right? So this is going to be, again, deaths versus damages from tropical cyclones 1900 to 2019. We know just the way we set it up last time, these are the deaths down there, so we probably should label it because it's really not going to be obvious. So, oops, I don't want that. All right, there we go. We want to add the primary x-axis down here. So the deaths log 10. All right, so we know what we're dealing with, and we should really do the y-axis as well, because again, these are really not going to be obvious. Sometimes when people produce these graphs, they'll not label them with the, well, they'll put in the actual original values rather than putting logged values, which is a little misleading about what's going on. So you kind of want to use, you want people to know what you're dealing with, and you also want to give them clear heads up of what's happening. Okay, so we've labeled them properly. Now we can see the pattern. Let's try adding the trend line and see what that tells us. So we'll add the trend line, and looks pretty promising. So I'm going to make mine again because I don't like that it's the same color. And rather than using a dash, we'll use a solid line. Yep. Okay. And then add our equation and the r square, and definitely an improvement in terms of the relationship. Before it appeared there was no relationship whatsoever, and now we've got a pretty strong one here. And it's definitely a positive slope. We can see that. So we can see then when we adjust for the skewed distribution of the data sets by taking their logged values, which makes them behave more normally, we get a more linear pattern. And again, this is why people do transformations of data, is to try to reveal patterns that might not otherwise be visible there. So we can see that there is a positive relationship between death and damage. Now, the interesting question to think about here, and this is something I leave to you to think about, is why is it that we have, or how is it that we have a positive relationship between death and damages, meaning when one is high, the other one is also high, when we look at the trends by contrast, for example, we see that while the damages clearly has a positive trend, it might not be well explained by a line, but it's clearly positive, it's rising over time, right? While the death trend is not so obvious, right, that it's definitely not rising, or it doesn't really look like it's rising, it's kind of dropping a little bit. But so those two trends are kind of, they're different, right? They're very different patterns. Yet when we look at the relationship between these two things, we have very different patterns. It's pretty strong. So the question is, how is it that you have a positive relationship between these two things, yet they have very different trends? So that's the question that, again, I'll leave you to think about.